All right, welcome to Little Astrophysicist. This is season 2, episode 4, and we're continuing to get ready for grade 9 math. The next 3 episodes are going to be all about rearranging and solving equations, which is very important, not just for math, but in science. This episode specifically, one-step equations. So we're starting simple. All right, I'm going to show you some examples. Now, if you look at the first example, we have minus 5 times x equals 45. Now, from elementary school, you can probably look at that and tell me what x is. Because if I were to say negative 5 times what gives you 45?
9.
Negative 9.
Yeah.
Yeah, right? 2 negatives will make you positive.
I hate negatives. Can we just take negatives out of this?
Nope, they're never going to go away.
Oh.
Fractions are going to be in the second example. And then double negatives in the third example. But even though in these one-step equations you can probably look at it and solve it, it's going to be important to know how we actually do this algebraically because questions will get more difficult later. All right. So what we have to do is right here, first step, we have to look at this and say, what's being done to x? In this case, x is being multiplied by negative 5. So x is being multiplied by negative 5. Now, if we're to undo this, to undo an operation, you have to do the opposite operation. So what's the opposite of multiplication?
Division.
Yes. So we're going to have to get rid of that negative 5 and to get x on its own, which we say to isolate x, get it on its own, we're going to need to divide by negative 5. However, very important, this is our rule right here. To make sure the equation stays true, whatever we do to one side of the equal sign, we have to do to the other side.
So divide by positive 5.
No.
What?
If we divide one side by negative 5, we have to divide the other side by negative 5. Think of it like this. 2 equals 2. That's a true statement, right? If I then multiply one side by 5, we have 10. If I don't do the same thing on the other side, this is a false statement, correct?
Yeah.
So I have to do the same thing on the other side. If I multiplied one side by negative 5, you'd get negative 10. So you have to multiply the other side by negative 5, or else it's no longer a true statement.
Yeah.
Okay. So let's rewrite this. We have minus 5x equals 45. Division we're going to do as a fraction. So if I divide one side by negative 5, and we're going to do a fraction because we don't use those division signs in high school anymore, we do the same thing to the other side. Try to keep it vertical. So negative 5 divided by negative 5 is 1. So that means we can sort of just cancel them because it just equals 1. And so we're left with x. So we've isolated for x. And 45 divided by negative 5 is, so there's our negative 9, solving algebraically. Make sense?
Yeah.
Okay. So, let's look at this one. What's being done to a?
Divide by negative 4.
Okay. And what's the opposite operation to division?
Multiply by negative 4.
Okay, so we're going to multiply both sides by negative 4. So if we have a over negative 4 equals 5, we multiply both sides by negative 4. See how we have negative 4 over negative 4, so they cancel, and they give us a, which equals 5 times negative 4 is?
I don't know negatives, bro. Hold on, let me think.
Alright, well, let's go over multiplication and a division. If you have two positives, so either multiplying two positive or dividing two positives, you get a positive. If you have a positive and a negative, you get a negative. And if we have two negatives, we get a positive. So here we have essentially a positive and a negative. So what do we get?
Negative 20?
There you go. Negative 20. Okay? Let's try one more and then you're off on your own. First of all, this one, let's simplify this one a bit. So we have b subtract negative 3. Two negatives gives you what?
Positive.
Okay, so that's going to be the same as b plus 3 equals minus 18. In this case, what's being done to b?
Plus 3.
Okay, so we're adding 3. How am I going to undo that? What's the opposite of addition?
Minus 3.
All right, so we're going to subtract 3. So if I do that to both sides, we have b plus 3. I'm going to subtract 3. Do the same thing over here. Subtract 3. 3 minus 3 is 0, so they're gone. We're left with b. And negative 18 subtract 3 is
15?
Why are you saying positive?
Because it's negative.
Okay, so this is for multiplication or division. Here we are taking minus 18, so on our number line, minus 18.
Oh, okay.
And we're
okay,
subtracting.
Okay. 21? Negative 21?
There you go, negative 21. Your turn. Let's try the first example.
No.
So what's being done to x?
Minus 5.
X is, we're subtracting 5
Oh, wait,
from x.
dividing 5, right?
That's
No,
what,
wait, multiplying 5.
There we
man.
go.
I'm confused because of that.
Okay. And how do we undo a multiplication?
Divide.
Okay, so do that.
$20?
Write your steps. Okay.
Oh.
If I were a teacher, this could be a 3-mark question. You would get 0.
Why?
Because 1, the answer is wrong. And 2,
What?
you haven't shown me any work at all. Okay, you just skipped and said x equals 20. Where did that magically come from?
Well, that...
So this is what you need to do. You write minus 5x equals minus 25. You told me you needed to divide by negative 5. So you do that to both sides that you have to write it.
Yeah.
This cancels. We get x equal to. There's a double negative. It's a division. So that becomes
so it's
what?
Positive, right?
Yep. And 25 divided by 5 is?
5.
There you go. So x equals 5. So you had the wrong answer, and you also didn't show me any work at all. Math, you have to show your work vertically, going down.
Okay.
Let's try question 2. What's being done to n?
What? Why is that here?
It doesn't really matter where we put the variable. It doesn't always have to be on the left side.
And minus n's being subtracted.
Okay, so how do we undo that?
Add.
Okay, let's write it out.
Add minus 7.
Add 7. If we're subtracting 7, we're going to add 7.
Okay, so. Wait, that's gotta be minus 7 plus 7, right?
Yep.
Alright. This makes a negative?
Negative 3 plus 7. Remember, we're not multiplying or dividing. You have to think of your number line.
Yeah. So that makes minus.
Start at negative 3 on your number line and add 7 to it.
4?
There you go.
So 4.
There you go. All right, question 3.
Doesn't that have to be...
It doesn't matter where you write the variable. It doesn't have to be n equals 4. It can be 4 equals n. It's the same thing.
Alright. So 1 equals n. Oh.
Yep. Okay.
5. 5, right?
Nope.
Why is that not 5?
It's not 6 minus 1. It's 1 minus 6. Start at 1 on your number line and subtract 6.
Negative 5?
There you go.
So I was right. It just wasn't negative. Oh my god.
That would make it wrong.
So negative
equals.
Oh man. N is dividing 9.
So how do we undo that?
5 times N?
Times 9.
Oh yeah, ma.
Why did you put 9 in the denominator?
Oh.
If you're multiplying by 9, it should go on top. So write your n divided by 9. And then multiply by 9. There you go.
Oh wait, my bad. Do I need that?
The equal sign? Yes.
But the other ones I didn't.
You have equal signs.
No?
You need one equal sign for each line.
Yeah, I have none here. That's a negative.
Yeah.
You never called me out. Disappointed, didn't you? 25, right?
Nope.
How is that not 25? It's 5 times 9.
5 times 5 is 25.
Oh, man. So, flip. 45.
There you go.
N.
Okay. So we had a little misunderstanding.
Nah,
There's one
that
equal
was so
sign.
easy.
One equal sign per line. That's it.
What?
Only one. You don't need to write equals 45 equals n.
Okay.
Just one equal sign per line. And one other thing I want to mention, just like I said, we don't use division signs, and like 5 divided by 5, we don't write like that. We write it like a fraction.
Yeah.
We also don't use x for multiplication. And the reason is because x we use as a variable. So this to me looks like 5 times x times 9. Okay. So there are different ways we can write multiplications. Sometimes we'll just do a dot. So that's 5 times 9. Or we'll do brackets. So that's 5 times 9.
I'd rather a dot. That looks silly, goofy, and nice.
You know, brackets can be helpful.
Nah.
We use both. And
I'd go for dot.
Okay. That is fine. All right. So I'm going to give you a bunch more questions to practice. And if everyone else would like to practice them, I'll put the handout in the description. You can download it for free.